Okay, today we are going to move into Unit 2, and we're starting with Lesson 3.1. We're going to be talking about solving quadratic equations by taking square roots. Later in this week, we're going to go back and talk about factoring. So it touches a little bit on factoring throughout this lesson, but not too bad. And then we will talk about it. It's not something that's in your book, so we're going to have to supplement it a little bit. So we'll probably do that Thursday and Friday of this week. So our essential question is, what is an imaginary number and how is it useful in solving quadratic equations? So this is something brand new that you've never seen before. We're not going to actually get into the imaginary number piece today. We're going to talk about it probably tomorrow. So we're going to kind of set it up today. We're working with our modeling standard again. We're going to see a lot of things represented with equations. We will also see a little bit of quadratics with the graphing and how to solve it with the graphing. But really a lot of with the equation, and we're going to really focus on some words today too, and what those mean. Okay. All right, so we're going to start with this explore piece. Okay. So we're going to investigate ways of solving simple quadratic equations. They're going to show us 3 different methods here. We're going to kind of go through the steps that they go through here. There are many ways to solve a quadratic equation. Here we use 3 methods to solve the equation x squared equals 16 by graphing, factoring, and taking square roots. So first we're going to solve this by graphing. First, treat each side of the equation as a function and graph the 2 functions, which in this case are f of x equals x squared and g of x equals 16. So basically, you graph each side. A parabola, I think we touched on that last week a little bit, but a basic parabola starts at 0, 0. If I had to, I could put in the point 1, 1. Or 1, and if I put 1 into x squared, I get 1, so I know the point 1, 1 is on the parabola. If I put in a negative 1, I get 1 out of it again, and then 2 would be, 2 is not 2. 2 would be 4, so, because 2 squared is 4, so I would be up here at 4 when I'm at 2, and so on, and so it should be making a U shape. And I really should be going through the 16. Sorry. Okay. Then we're supposed to graph the g of x equals 16. So we would be right through here. And luckily, my 2 things crossed in the right spot. If not, I wouldn't have gotten the right answer. So they really intersect. I should have really done that in better detail. It really intersect at -4 and 4. Because they're looking at the x values where they intersect. All right, this is by factoring. So I'm going to step through it, and we'll talk kind of about which factoring this is. This method involves rewriting the equation so that 0 is on one side in order to use the zero product property. And you're going to hear me harp on that zero product property quite a bit, which says that the product of 2 numbers is 0 if and only if at least one of the numbers is 0. Okay. So we're going to start by writing the equation, and then they subtracted 16 from both sides. Then we're going to factor with what we call difference of squares factoring, and that's as much factoring as we're going to do. There's one in the homework that goes beyond that. We're going to skip that one till we relearn how to do it. So when we have difference of squares factoring, when we factor into a binomial times a binomial. Then we take the square root of whatever your first term is, so square root of x squared is x. We take the square root of the second term, which is 6, or square root of 16 is 4. We make 1 a plus and 1 a minus. Okay. You have difference of squares factoring because there are 2 terms, they're squared, and there's a minus sign in between. Okay. So then to apply the zero product property, what that basically says, or what the process is you basically take these 2 factors and you set them both equal to 0. And that process of doing that is called the zero product property. Then we're going to go ahead and we're going to subtract the 4 and add the 4, and we get x equals -4 and 4, which is the same thing we got when we graphed it. This was way more precise, though. I could have really messed up this graph and not graphed it very precisely and not gotten the right answer. So doing it by factoring gets me a precise answer. This is going to be doing it by square roots, which is really our focus for today. So a real number x is a square root of a non-negative number. We probably should underline here. A provided that x squared equals a. A square root is written using the radical symbol. every positive real number a has both a positive square root written square root of a and a negative square root written negative square root of a. For instance, the square roots of 9 are plus or minus square root of 9 or plus or minus 3. The number 0 has only itself as a square root, so it's plus or minus square root of 0 is 0. So we're going to write the equation. To undo a squared, we take the square root of both sides. When we take the square root on the right side with a number, we always write a plus or minus in front of it. The square root of 16 is plus or minus 4. You can leave it as a plus minus for your answer. You don't have to write it x equals 4 and x equals negative 4. Notice 3 steps. 1, 2, 3, 4, 5 steps. So the square root was most efficient when we had this kind of a setup. All right, so I'm going to reflect a little bit. Which of the 3 methods would you use to solve x equals 5? Explain and then use the method to find the solutions. The hard part about the graphing, so if I did that by graphing, so here's my parabola, right? And then my x equals 5, 1, 2, 3, 4, 5. 5 isn't a pretty square number, so I'm not going to get very exact answers here. They would only be approximate answers. So graphing produces only approximate answers. All right. The factoring method. Okay, so if I did this by factoring, I'd have to start by subtracting 5. So x squared minus 5 equals 0. This isn't a square number, so I can't use difference of squares factoring. So by factoring, five is not a square number. So it isn't a difference of 2 squares. So it isn't a difference of 2 squares. Okay, and then the final one would be the square root. So is it possible to take the square root of both sides? I think it is. It would just give us what we call an irrational answer, but it's okay. It's irrational. It's just going to produce a decimal point if we put it into our calculators. So you could say, however, taking the square root gives x equals plus or minus square root of 5. Okay, so can the equation x squared minus 9 be solved by any of the 3 methods? Explain. So let's think about that. X squared and negative 9. So if I graphed it, my negative 9 would be down here. It wouldn't cross. So graphing method doesn't work because B/C is because graphs do not intersect. So graphing does not work. Method doesn't work because graphs don't intersect. Okay, let's talk about the factoring method. So we would have to add the 9. Okay, they are squares, but the problem is they're not a difference of squares anymore. So factoring doesn't work. Factoring doesn't work because x squared plus 9 equals 0 is not a difference of squares. Of squares. Okay, sorry, got too close to the edge. All right, then finally we're looking at the square root method. So let's talk about the square root method. If I went to go ahead and take the square root of both sides, we now have a square root of a negative. You can't do that, at least not yet. That's tomorrow, okay? But we're going to talk about tomorrow how you can do that. But as far as you know right now, you can't do that. So square root doesn't work because you can't take the square root. No, it's not right for me. Root of a negative number. All right, so we're going to try to get through explain 1 and 2 today. Okay. So when solving a quadratic equation of the form ax squared plus c equals 0 by taking square roots, you may need to use the following properties of square roots to simplify the solutions. In a later lesson, these properties are stated in more general form and then proved. So this first one, product property of square roots, the square root of a product equals the product of square roots of the factors. Basically what we're doing here is if we've got a number and we want to split it up, we split it into, I usually do it into 2 square roots. A number we can take the square root of and a number we can't take the square root of. So let's talk about our square numbers really quick. 1 squared is 1. It's not a bad idea to write this in the left-hand column somewhere. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. That was a 21. 13 squared is a 169. 14 squared is a 196. 15 squared is a 225. I would probably know 25 squared as well, which is 625. So if you hit any of these numbers in this right-hand column, those are the square numbers. So that's what you're allowed to put in this first box because you can take the square root of it. I call it a can-do box and a can't-do box. Whatever's left over goes in the can't-do box. Whatever's in this can't-do box, you shouldn't be able to take the square root of. So we have the square root of 4 times the square root of 3. Square root of 4 is 2, and then we just drop the square root of 3. Okay, so that was my mini lesson on how to take the square or how to simplify a square root. Quotient property of squares. The square root of a fraction equals the quotient of the square roots of the numerator and the denominator. So basically what it's saying here is I'm allowed to take this square root and split it into 2, and then I can just take the square root of the denominator, which in this case was 3. But there's another little piece to this. So using the quotient property of square roots may require an additional step of rationalizing the denominator. That's a big thing. If the denominator is not a rational number, meaning not a nice, pretty whole number, okay? For instance, the quotient property allows you to write 2 square root of 7 as square root of 2 over square root of 7. But 7 is not a rational number. It's an irrational number. To rationalize the denominator, you multiply square root of 2 over square root of 7 by square root of 7 over 7, which is basically the number 1. Multiplying by itself gets us the radical out of the denominator. This is the result. So square root of 2 times square root of 7 is 14. You multiply insides together. Square root of 7 times square root of 7 is square root of 49. And so the square root of 49 is 7. Most of the time, students at your level here, a radical times itself is whatever's inside, and we skip this step in the middle. Okay. All right, so we're going to solve a quadratic equation by taking square roots. We're going to start by adding 16 to both sides, which is what they did here. Then we're going to divide both sides by 2, which got me the 8. Then I'm going to take the square root of both sides, which when we do square root of the number on the right, we write plus or minus. Then I separate into the 2 boxes, the can-do box and the can't-do box. So I can take the square root of 4, and I can't do the 2. If you have to go back and do factor trees, you can. Okay, that is another method to getting the finding the simplified version of this. The square root of 4 is 2, so you've got 2 square root of 2. All right, let's try this a little bit together again. They've stepped it out for us a little bit. It says we're going to start by subtracting 9 from both sides, which gives me negative 5x squared equals negative 9. It says we're going to divide by, it looks like we divide by negative 5. So negative and a negative would be positive 9/5. We're going to undo the square by taking the square root of both sides. So we've got plus or minus the square root of 9/5. Use the quotient property, so that means they just want us to split this up. Simplify the numerator, so they're saying the square root of 9 is 3 over square root of 5. Then it says we have to rationalize the denominator. So I'm going to multiply top and bottom by whatever's in the denominator. Across the top, I cannot multiply the 3 with the 5 because they're out. One's outside and one's inside, and they don't mix together. So square root of 3 over 5. Radical 5 times radical 5 is square root of 25, which is just 5. So radical times itself is the number that's underneath. It's our shortcut. All right, we're going to try to solve this, do a couple on our own here. So we're going to start by adding the 24. So you've got x squared equals 24. We're going to undo the square. We're going to take the square root of both sides. On the right side, we should write plus and minus in front. I'm going to look for the biggest square number. So the hard part about this can and can't do box is I want the biggest square number. Biggest square number. Okay. So if I think about square numbers that go into there, I could do 4. The next 4, that's 2 squared, 3 squared is 9, 4 squared is 16. So does 4 divide this? Yes. How many times? 6. That's not divisible by a square, so 4 has to be the biggest. A very, very common mistake is thinking that 8 is a square number. 8 is not a square number. Okay, so you can't use that one. So the square root of 4 is 2 square root of 6, and we'd leave our answer like that. All right, looking at number 4. So I'm going to start by subtracting 13 from both sides. So you've got negative 4x squared equals negative 13. We're going to divide by 4. Double negative is going to go positive. We've got 13 over 4. To undo the square, I'm going to take the square root of both sides. On the right side, I'm going to do a plus or minus. So let's see. Now, you could split this into 2. I don't typically. I just say there's a square number in the bottom, so I'm just going to take the square root of it. The numerator is going to stay square root of 13. The denominator is going to be square root of 4 is 2. I don't need to rationalize because the square root is gone. And I did not drop. I messed up. Hold on. This square should not be there anymore because I took the square root. All right. So we're going to do explain 2, and then after explain 2, we are done for today. Okay? So, solving a real-world problem using simple quadratic equations. So, 2 commonly used quadratic models. So, here's where we're actually getting some of our modeling in. Outside of using equations, these are actual modeling problems. The Earth's surface are follows. So, this is just a general equation. It has to do with gravity, I'm sure. But the distance fallen in feet is this equation. So, if they say distance fallen in feet, you can automatically assume that equation. Height in feet, we start with what we call an h, or it's h of t equals h sub 0, or sometimes they'll say h sub naught. That's the initial height of the object. And then, so they might give that to you in the problem. And then they subtract whatever this distance is, okay? For both models, time is measured from the instant the object begins to fall. A negative value of t would represent a time before the object began falling, so negative values of t are excluded from the domains of these functions. So we basically exclude negative values because it doesn't make sense to have a negative distance. This means that for any equation of this form, where c is a constant, a negative solution should be rejected. Okay, so let's see what they do with this. So we're supposed to write an equation to answer the question, give the exact answer. If it's irrational, a decimal approximation to the nearest tenth of a second. I'm going to say 3 decimals. Always, okay? No matter what the instructions say, I always want you to leave 3 decimals. That's because of what we do in AP Calc. Okay. And their answers here, I'm probably not going to be able to do that because I only have the book's answers. I'm not using a calculator. But if you can use 3 decimals with a calculator, use 3 decimals. All right, so if you drop a water balloon, how long does it take to fall 4 feet? Well, 4 feet is a distance, so we're going to use this distance model that they gave us. And we know that the actual distance is equal to 4. So basically, these two things get set equal to each other. So that's what they did. They wrote the distance equals 4. All right, we're going to divide by 16. And then they reduced their fraction because both 4 goes into both 16 and 4 and 16. So 4 goes into a 4 once and into 16 4 times. Now we're going to square root both sides. And technically you could use a plus minus. Okay, we'll start there because that's what we've been trained to do. So we've got plus or minus square root of 1/4. And then we're going to go ahead and take the square root of 1, which is 1, and the square root of 4, which is 2. So we got a nice, they were both nice square numbers, so we didn't have to mess with any rationalizing. Now, it doesn't make sense to drop a negative distance. So we exclude the negative value, and we know the water balloon falls 4 feet in 1/2 of a second. All right, so this is a slightly different scenario. A rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon dropped from the rooftop to pass a 3rd-story window at 24 feet? So they skipped like 3 steps here with you guys. They went from that really simple one to one that's really complicated. So we're supposed to use this model here. This here would be our h of 0, okay, or h sub 0. And then we're supposed to, and the solution, how far we're supposed to get in the picture, is we're only supposed to get to 24 feet. So this would be the h of t, okay? It gives you a little hint there, but we'll go through it when we hit it. So we're going to write the equation, 50 minus 16t squared equals 24. I'm going to start by subtracting 50 from both sides. So 24 minus 50 is negative 26. And then we're going to divide by the negative 16, which is going to go positive. And, oh, actually, this is their little hint. Don't try to reduce that number. Leave it as 26/16 because the 16 is a square number. If I reduce it, it's not going to be square anymore. So this actually helps us. We're going to undo the square root by undo the square by taking the square root of both sides. We put a plus or minus in front. We get square root of 26 over 16. The square root of 16 is 4. The square root of 26 can't be broken down, right? 26 is 13 and 2. There aren't any square numbers that go into that. If we did put this in our calculator, okay, first of all, we dropped the negative answer. So they're saying it could be 26 over 4. Square root of 26 over 4. Perfectly good answer. Doesn't make much sense in this case because decimals would make more sense because you can't really, you're not going to go to the store and get a tape measure that's has square root of 26 over 4. You're not going to, sorry, it would be a stopwatch. It's not going to do square root of 26 over 4 seconds. The book is saying 1.3 again. I want you, if it goes more than a decimal point, then I want you to go to 3 decimal points. All right, so we're going to reflect a little bit, and then we've got 2 to try on our own. Explain how the model h of t equals h sub 0 minus 16t squared is built from this model right here. Okay. Well, we know that this is the initial value. So we know that h sub 0 is actually it's the object's original height. Original height. Okay. So this piece here, if I have something to substitute in there to solve for the time, is really how far it's actually falling. So h of t is, actually it's the distance, that it's the distance left to fall, is the distance left to fall. All right, we're going to write and solve an equation to answer the question. Give the exact answer, and if it's a rational, a decimal point approximation to 3 decimals. if you can. Again, my examples are only going to show one, but I want you to go 3. How long does it take the water balloon described in part B to hit the ground? Okay, the height at ground level would be 0. So our distance would be 0. Okay, so I'm going to take that same equation, the 50 minus 16t squared, set it equal to 0. I'm going to start by subtracting 50 from both sides. And then we're going to divide by negative 16. And I'm not always going to show all those little tiny steps. You don't have to either. Double negative is going to go positive, and we're going to use that same trick. We're not going to simplify that, even though we know 2 goes into both of those. Okay? We're just going to go ahead and take the square root of both sides because that's a nice, pretty square number. We know we put a plus or minus on the right, so square root of 50 over the square root of 16 is 4. Now, that's not simplified all the way because I can break that 50 down. I can break it into a can and a can't-do box. So the biggest square number that goes into 50. So let's see, we've got 4, 9, 16, 25, 36. I know 25 goes into both of those. So square root of 50 square root of 50 breaks into 25 2 times. Square root of 25 is 5, square root of 2 over 4. Again, that's a perfectly good answer. We would want to drop the negative, so we would know our final answer is 5 square root of 2 over 4. Or the book is telling me, you guys can check the decimal point, that it is 1.8 seconds. Okay? All right, one more really quick. I think I've got 2 babies crying right now. My husband is watching them for me. On the moon, the distance d in feet that an object falls in time t in seconds is modeled by this function right here. So they gave us the function. Suppose an astronaut on the moon drops a tool. How long does it take the tool to fall 4 feet? So this is the distance we're falling. So we're basically setting those 2 things equal to each other. So 8/3 t squared equals 4. And if you wrote it backwards, it wouldn't be a big deal. If you like it that way better, it's the same thing. I need to get this to the other side, so I'm going to multiply by the reciprocal. And the nice thing about that is 4 goes into 8 twice. So I've got t squared equals 3/2. I'm going to undo the squared by taking the square root, put a plus or minus in front. So now this time, I can't do anything with, there are no square numbers, so I have to rationalize. So I'm going to multiply top and bottom by the radical 2. So t equals plus or minus square root of, so square root of 3 times square root of 2 is square root of 6. Square root of 2 times itself is square root of 4, or just 2. These do not simplify because one's on the inside and one's on the outside. And then we would take away that negative value, so we'd say it's square root of 6 over 2. Which they are telling me is 1.2, and you want to make sure you label it because it was a word problem, seconds. All right, you should be today, and it probably wouldn't be a bad idea to do this today, go to your elaborates at the end of the lesson here, and you should be able to do number 15 today. Okay, so why don't you go ahead and do that.